Now let's discuss some insight into phase angles. Suppose I have an object oscillating with amplitude 28 centimeters. So that's its maximal displacement, how far it'll ever go. And someone tells me that at t equals 0, the object has a position of, so at t equals 0, x is negative 12 centimeters. Okay, in previous videos we've talked about solutions that look like a cosine omega t, a sine omega t. But this won't work here, because if I have t equals 0, cosine will give me back a. If t equals 0, sine will give me back 0. So what do? I use something called a phase angle. So we need to pick whether we're going to use cosine or sine, and the way to do that is to think about the sine of this x. So this gives me back a negative number. Usually phase angles fall between 0 and pi. The reason for that being, if I was going to use a bigger phase angle, I'd probably just need to switch whatever trig function I used in the first place, because these are offset from each other. So why not just switch my trig function and make things simpler? So assuming this principle holds, that we're going to pick a phase angle between 0 and pi, if you think about possible angles, so remember cosine gives me back x and sine gives me back y, if I'm just thinking about rotating a unit line around here. Well, y is positive or 0 for all things between angles 0 and pi. Oops, it's a terrible pi. So it would have to be the cosine function, because once we get past pi over 2, it gives back negative answers. So I'm going to pick cosine just because that makes things simpler. I don't have phase angles going crazy down here. And that's often the physicist's way of solving a problem, is what one makes it easier. So our phase angle we'll determine using cosine. So that means that x of t equals a cosine omega t plus some phase angle, and that's what we're going to solve for. Well, if I plug in t equals 0, because that's what the problem told me about, I get a cosine my phase angle. And then it's just a matter of solving this out. So the problem gave me a number, so negative 12 centimeters equals 28 centimeters cosine phi. Then I take the, first I divide, so negative 12 centimeters over 28 centimeters, and then I'll take the inverse cosine, and that should give me back phi. And when I do that, I get phi equals 2.01 radians. Okay, well, let's suppose that this thing has a period of 2 seconds. I want to write out the mathematical function for this object as a function of time. What do? Well, we've already got pretty much all the information that we need. We need this thing to circle around in 2 seconds. What would do that? Well, both of these functions here would need something that would cause them to repeat whenever t is 2. So what would cause a repetition at p is 2? T is 2. If we look back at our axes, we get back to wherever we started whenever we've gone around 2 pi. So no matter where we started, let's say we started here, if I circle around 2 pi, I'm back to that place. So it makes sense that my omega would just be pi. We already picked a cosine in the last part of the problem, so now I just put it all together. A cosine pi t plus my phase angle would give me 28 cosine